Now let's look at some basic topics in chapter 12. This is from section 1. Now, for this section, the most important thing we need to remember is the distance formula in 3D coordinate system. So let me write it on the top over here. So we have a three-dimensional space over here. And assuming we have 2 points, say one point over here, we have A, B, C coordinates, okay? And let's say we have another point over here, and we have X, Y, Z. The derivation of the distance formula is just straightforward. You apply the Pythagorean theorem twice. It's in the textbook, so I'm not going to repeat that part. So if you want to find the distance, it's the diagonal of a rectangular prism. So the distance formula is this. Sometimes it's easier to remember that distance squared is equal to x minus a squared, the x coordinates, the difference, plus y minus b squared, and plus z minus c squared. And this is just an extension of the Pythagorean theorem in three-dimensional space. We know in two-dimensional space, we just don't have the third dimension, and that's exactly the same. Okay, so this is the basic thing we need to know for this section. And almost every exercise is surrounded at this basic formula. So if you want to find the distance d, then you can take the square root. Okay, it's a long formula, but there is nothing really special about it. Okay. After this one, there is another important concept. We know when we look at the distance between 2 points, that's usually we say the shortest distance we actually have. What about, say, you have a point and another plane or another line? Just remember the following statement, that for any two objects, the distance between them is the shortest distance you can find between 2 points. So imagine if you have just a line over here, you have a point over here. Let's say in 2D. So what is the distance? The shortest distance you can find between this line and this point. So the shortest one over here is this over here. And we know this one over here must be a right angle for this one to be true. And we will have this kind of many of this type of problems later on. Okay, so after this short introduction, now let's look at several specific problems over here. Number one, this point is just given arbitrary. Say we have a point A, and see how the point is expressed in this textbook. You have point capital A, and then the coordinates inside a pair of parentheses. So that's how we write down a point explicitly. Okay, so what is the distance between this point A and the YZ plane? So the easiest way, of course, is try to sketch a diagram. You say, okay, we use the standard diagram over here. This is X, this is Y, and this is Z, right? And this is YZ plane, but we just try to see this is 0 over here. So YZ plane over there. Now, where is point 2, 3, 5? Now, you still use the same method we actually learned in calculus 1. So imagine if you have two-dimensional space, you have something like this, right? If you have a point 2, 3, and then see this is 2, and it doesn't have to be to the scale. So this is 3, and then this point over here is 2 and 3, right? So we do the same thing, but because this is three-dimensional space, so we try a little bit harder to write to try to find this point. So over here, this is 2. X is 2 on the x-axis, and on the y-axis is 3. Okay, so 3, and on the z-axis is 5. So at 5. So how can we find this point? we can use the following way. You look at 2 and 3, this point over here, in the xy plane. You draw a parallelogram in the xy plane and draw over here. So this point over here will be x is 2, y is 3, and z is going to be 0. After you have drawn this point, and then you try to find the z coordinate. Okay, so try to see if it makes sense. You're going to actually draw another parallelogram, but it's going to be in 3D, so it's over here. And this point over here is going to be your x is 2, y is 3, and z is going to be 5. Okay. Now, if you have negative coordinates, it's going to be on the other side. This is so-called in the first octant, right? So we draw this dotted line to indicate where this point is, to give us some kind of sense of 3D graph. Okay. So now we want to find out where, what's the distance between this point and the YZ plane. So what we need to do is somehow draw a line perpendicular to the plane. And you can see this is going to be something that I'm going to try to do. It should be parallel to the bottom one and this point over here. That's the point closest in the YZ plane to this point. If you want to find the coordinates, this one over here, in the YZ plane, x is 0. So this point over here is 0 and 3 and 5. So now you're trying to find the distance between these two. So the distance between these two, we can try to use this formula over here. You have a point over here, and so the distance, let's do this. This point is A, this point is B, right? So we can try to use a notation like this. So what's the distance between A, B? I think this is the notation we have in the textbook. Now, according to the formula, this is going to be the square root of these 2 points. So you'll see 2 minus 0 squared, right? Let me be careful over here. It's 2 minus 0 squared, and plus 3 minus 3 squared, and plus 5 minus 5 squared. And we see exactly it's 2. In fact, that is the meaning of the first coordinate. 2 over here means the distance from this point over here to the YZ plane is exactly 2. So 3 means the distance between this point and the XZ plane is 3. And last coordinate 5 is the distance between this point and the plane XY, right? The plane XY. Okay. So that's how we find the distance between one point to the coordinate plane. All right, now let's look at the next one. What is the distance from A to the x-axis? This time, we're going to use a different, slightly different method, because here we used a geometric method, right? So we are now going to use an algebraic method over here. So point A over here, we have 2, 3, and 5, right? Let's try to make it a formal solution, right? And what kind of coordinates we have on x-axis? On x-axis, we have the following points. Because it's on x-axis, so we have the first one is x, and y is 0, and z is 0. And this point is on x-axis. X is an arbitrary point. So any point, let me call this P. So what's the distance between A and the P? And that's going to be square root over here. And then we have 2 minus x squared, right? And plus 3 squared. and plus 5 squared, because it's minus 0, right? So if you look at this one over here, the distance over here is going to be square root over here is 2 minus x squared and plus 9 plus 25. So that's going to be square root over here, 2 minus x squared and plus 9. Oh, that's going to be 34. Okay, so that's going to be 34. All right, it's going to be 34. Now, we want to find the shortest distance. So when we can easily see when x is equal to 2, AP is the shortest, is the smallest. Smallest, that means it's the distance from this point A to x-axis, right? So what it means is that on this x-axis, when x is equal to 2, then we have the distance. Then we have the distance. Okay, and that means the distance between this point and the x-axis is, so the distance between A and x-axis is square root of 34, okay? All right, let's pause over here because we still have 2 problems